In this chapter, we are going to learn projectile motion, 拋物線運動. When a body is projected downward with an initial speed u, it will follow a path like this one. This path is called projectile motion. For a projectile motion, it has both vertical motion and horizontal motion as well. Its vertical displacement is called y, while its horizontal displacement is called x. Consider at time t, the body moves to the point here at time t. At t, the force on the body is vertically downward, which is equal to its own weight, mg. For the downward motion, Fy equal to mg, May equal to mg. Therefore, it has a downward acceleration ay, which is equal to g, equal to 9.81 meter per second square. Then, what will be the vertical speed or vertical velocity Vy at time t? Vy equal to uy plus ayt, which is equal to u sine theta plus gt. Then what will be the vertical displacement y at time t? At time t, y will be equal to uyt plus half ayt square, which is equal to u sine theta t plus half ayt square. Hence, for vertical motion, we can use ay equal to g to find vertical acceleration. Also, we can use Vy equal to u sine theta plus gt to find vertical speed. Finally, we can use y equal to u sine theta t plus half ayt square to find vertical displacement. Then, how about its horizontal motion? During its motion, there is no horizontal force acting on the body. Therefore, Fx equal to 0, implying that acceleration along the x direction is also equal to 0. Therefore, the horizontal speed Vx at any time t is equal to the initial horizontal speed ux at any time, which is equal to u cosine theta. Also, the horizontal distance traveled at any time x is equal to horizontal speed Vx times time t, which is equal to u cosine theta times t. As a conclusion, for the horizontal motion of a projectile motion, there is no horizontal acceleration. That means ax equal to 0. Also, the horizontal speed vx is always a constant value, which is equal to u cosine theta. Lastly, the horizontal displacement traveled by the body is equal to u cosine theta times t. What happens if the body is now projected horizontally at a speed u? Due to gravity, the body will also perform a projectile motion like this one. Let's consider a subsequent horizontal motion x and vertical motion y. For its vertical motion, we still have ay equal to g, but now we have uy equal to 0 since it is initially projected horizontally. Therefore, there is no initial vertical speed. If at time t, the body moves to a position as shown in the diagram, then its vertical speed vy would be equal to vy equal to uy plus gt, which is equal to gt since uy equal to 0. Also, its vertical displacement y would be equal to y equal to uyt plus half gt squared, which is equal to half gt squared only, since uy is again equal to 0. For its horizontal motion, we have a along x equal to 0, implied we have v along x-axis equal to ux, which is equal to u. Since the horizontal speed is a constant u, therefore its horizontal distance x at time t would be x equal to vx times t equal to ut. The horizontal speed at time t would be equal to u. Okay, in this case, we have vx equal to u all the time. The velocity at time t is a tangent to the point. Okay, v, where v equal to square root of vx squared plus vy squared. Lastly, what will happen if the body is projected upward at an angle theta with the horizontal at a speed u? Similarly, it will also possess a projectile motion like the one shown in the diagram. Again, let's consider its vertical motion y and horizontal motion along this x-axis. For its upward motion or vertical motion, the initial vertical speed uy is still equal to u sine theta. However, its vertical acceleration ay would be equal to negative g instead, because it's moving with upward deceleration. if at time t the body is at a position as shown in the diagram, then its vertical speed Vy at t would be Vy equal to Uy plus Ayt, which is equal to U sine theta minus Gt. Also, its vertical displacement y would be y equal to Uyt plus half Ayt squared, which is equal to U sine theta times t minus half Gt squared. How about at time t, its horizontal motion is? For its horizontal motion, we still have acceleration along x-axis. Ax is still equal to 0, and its initial horizontal speed Ux equal to U cosine theta. Since Ax is equal to 0, that is to mean that its horizontal speed is always a constant value. Therefore, at time t, we have Vx still equal to Ux equal to U cosine theta all the time. Also, its horizontal distance traveled x would be equal to Vx times t, that is equal to U cosine theta times t. So far, we have studied 3 different cases of projectile motion. Case 1, the body is projected downward at an angle theta to the horizontal. Second, the body is projected horizontally. Thirdly, the body is projected upward at an angle theta with the horizontal. All these cases have the following things in common. First, air resistance is negated. Second, its horizontal speed is constant throughout the motion. That is, Vx equal to the initial horizontal speed Ux at all times, which is a constant value. For downward motion, its vertical acceleration Ay is a constant, which is equal to g. For its upward flight, the upward acceleration Ay would be equal to negative g instead. D. For a projectile motion, its upward motion is independent of its horizontal motion. In fact, its upward motion is a free-fall motion, which is affected by the gravity only, while its horizontal motion is unaffected by gravity.